Hey, welcome back. Today I'm going to be talking to you about how you can build a honeypot using Python and the Google Gemini LLM models. And we're going to be using a methodology for building an AI agent in Python that's called ReAct. And this is really where you're combining the acting and the reasoning functions together in kind of an iterative loop. And using that loop, you're going to be able to take certain actions and answer certain questions about the user's query. So for example, the prompt that came in here, I believe, was what was the original software in which the Apple remote was originally intended to be used with. So let's say the user sends in that prompt, and then the LLM is going to use its knowledge to have a thought, right? So that's thought number one right here. And it's going to say, oh yeah, I need to search Apple remote and find the program originally designed to interact with. So then the act one, maybe it calls a search tool and searches for the string Apple remote. And then based on that, it's going to get some web pages and it's going to observe those, and then it's going to have this observation. It says, oh, that Apple remote was originally introduced in October 2005 by Apple, originally designed to control the front row media center program. Now, if you can remember the front row media center program, yeah, you old. No, just joking. So yeah, I remember when that remote first came out, and I actually used this in my college days to do a presentation. So yeah, things, seemed like yesterday. All right, then, maybe they'll have another thought based on that observation, the LLM will, and maybe you'll do another search, like what is front row? Then we'll find out an observation about that based on that data. It just kind of loops around through this thought, action, observation loop until it is sure it has the right answer, and then it sends that back to you, the user. So we're gonna build something pretty similar to this inside of our Python base, but as a honeypot. And you should be able to check out this code on the GitHub, but there's really only a few files here. Most of the logic is gonna be inside this app.py file. And so yeah, let's just jump over and start diving into the code. Okay, so for those of you that have watched the channel, I like using the dev containers extension for VS Code or Cursor, which allows me to have a new container for each project that I'm working on. The setup.sh file, this is how I typically set up my container when it's inside of the Ubuntu 22.04 Docker container. We can see it's gonna install the request library. It's also gonna install this Paramiko library, which is used to create the SSH daemon. And then when we go to run this, we're just going to remove the logs so we can ensure we're in a clean state. And then we're just going to run the honeypot Python file. I did include the zclean file as well. So if you go ahead and run that, it will make sure you're in a clean state. Get rid of all the old logs. Okay, so then inside of the main application file, when we call this, it's going to jump to this function main. It's going to check to make sure we got the API key. That's going to be inside your app.ini file. We're using the Gemini 2.0 Flash experimental model because it's fast and cheap and pretty good. And then we'll have the API key that you'll need to populate here. And then as long as we have that set up, then it'll start up the honeypot. The honeypot is going to use that Paramiko library. We're going to generate an SSH key. We're going to bind to port 22. We're going to bind to 0.0.0.0, so any interface. And then we're going to, just display a banner saying, hey, we're listening on 22 now. Now, anytime that we get a connection, we're going to go ahead and use this threading.thread to handle the client that's connecting. And so we'll jump up there and see what that kind of looks like. All right, so here's the handle client. I'll pass in a couple of things like the client address, the host key. But we're going to make the logs directory then, and we're going to start, timestamping the logs. And we're basically going to just record any command and any response that we get from a user. Now, we're going to go ahead and authenticate the user to the system. And the way that I have this set up is it will allow any username with any password to authenticate as long as the username is not on the blocked username list, and as long as the password is not on the blocked password list. This is just because there's like a bunch of worms on the internet that are, automatically using these really weak credentials. And so I'm kind of blocking some of those worms in this scenario just because I want to, get a real interactive attacker to come into this honeypot and waste their time. Okay, so you can see inside of the SSH honeypot class that you can see the check off passwords. We're going to record in the credential files all the usernames and passwords that ever get attempted. We're also going to implement the blocked passwords and blocked usernames. And if it's not blocked, it's just going to successfully authenticate the user. Once we do that, we're just going to give the users a hash prompt. or a $ prompt and send that back to the user. And then the user is going to be kind of stuck in this loop, right? Where, whatever command the user sends us, we're going to write to the commands file. And once we do that, as long as the user doesn't run the exit or logout command, we're going to go ahead and read this prompt template. And then we're going to populate some of these variables within the prompt template based on what the user's provided to us. So let's look a little bit at that prompt template now. Okay, so this prompt template says, you are simulating a Linux server for a medical device company. Your task is to provide realistic responses to Linux commands as if you were a real terminal. Follow these instructions carefully. So number 1, environment setup. This is a Ubuntu 20.04 LTS system. Commands processing. So here we're going to put the command that the attacker gave us that he wants to run. Here we're going to put the username that the attacker authenticated to the remote SSH system, just so we can make it look and feel more authentic. We're also going to pass a host name just to kind of get some consistency in the responses from the LLM. And then we're going to say, hey, generate a response, analyze the given command, and determine how a real Linux system would respond. Consider the context of the company. For commands that list users or show information, include realistic data that would be expected in this company's servers. Maintain consistency with previous responses if multiple commands are processed in a sequence. The user is already logged into the system. Okay, and then now we're going to specify the output format. So we're going to give it this tag, reasoning for response. So for some reason, certain LLM models love to give you more information than you really need to know. And so typically I just give them a section where they can dump any data they want. And then I can either, use that data as part of my debugging, or I can just, throw away that data when it comes back from the LLM. And then here we go. We got response to command, the simulated Linux terminal output, and the response to the command. Output should be included the command's results without showing the command prompt string, i.e. do not show user at host, $. Remember to stay in character as a Linux terminal throughout your responses. Do not break the fourth wall or acknowledge you are an AI language model. Respond only as a Linux terminal would, with the exception of the reasoning for response section. So there you go. That's kind of the bulk of the meat of the honeypot prompt. We're going to send the query to Gemini using the properly formatted prompt. We're going to take whatever response we get and write it to the session files. We're going to parse out the responses, parse out the reasoning, and then we're going to send the answer that we get from the LLM back to the attacker, so it will look and feel like a real Linux environment. Okay, that's kind of long and short of how this works. So let me go ahead and demo this for you now. So I'm going to go ahead and start up the honeypot server. I'm just going to run the .run sh script. It's going to have the honeypot listed on port 22. So you might need to reconfigure your SSHD daemon so it's not listing on 22, it's listing on some arbitrary high port, so you can run the honeypot there. Then we're going to go ahead and SSH in as the user Bryce to this server's loopback address, which is 127.0.0.1. The user Bryce is not on the block list, so if we SSH in, I got an error because I already had done this once before, so it already had generated a known host key. And then when I restarted up the honeypot, it generated a new known host key. So I'm just gonna need to go in and remove the previous configuration. And I just copied this command to do that. So if you ever see that error and you know it's safe to connect, then just run that command to clear it out. All right, let's try it one more time. So this is the context of the attacker. He's gonna SSH into the system. And then, you can just put any password, and then now he's at the terminal. So maybe he runs ls tac alf. So now the honeypot's going to take ls tac alf. It's going to send it to Google Gemini in that prompt template. It's going to get back something that looks like this in between those tags. It's going to extract that from the tags, and then it's going to display it back to the attacker. So there's like an access log.txt, so maybe we can go and like cat that. Now, none of these files really exist. Like the LLM is just making this up as it goes. And here you can see, there's an access log or something that would kind of look like it. And then maybe the attacker's like, well, maybe I can, go see what's going on at /etc. And all this data is getting relayed back and forth to the Google Gemini APIs. So there is sometimes a little bit of delay. It just depends how long it takes for things to come back and forth. And now we get something that looks kind of like that. And then maybe they say like, oh, show me /etc password. And so the request is going to get sent to the Google Gemini APIs, and it's going to, make up the response here. And then maybe, You could say like cat/Etsy shadow, which would have the password hashes in it typically. And then it's going to say permission denied. So, maybe we could say like, who am I? And then the LLM's going to say Bryce, so it remembers who we are. And, maybe we can say like uname tag A. And remember, we set it as a Ubuntu system. So that looks pretty accurate for a Ubuntu system. Even says Ubuntu right there. All that goodness. And then if the attacker types exit, he'll disconnect. So, that's basically the honeypot in a nutshell. All right, well, I appreciate you tuning in and learning a little bit more about how to build, Python applications that are acting as AI agents. And if you have any questions, just leave them in the comments below. Like, subscribe, and, really appreciate you guys supporting me in the channel. And I will see you in the next one. Thanks. Bye.